Welcome to solverfy.
So here in this question, to determine the angular velocity and angular acceleration of the bar, we need to consider the relationship between linear velocity and angular velocity for a rotating object. The linear velocity v is equals to omega into r, where v is the linear velocity, omega is angular velocity, and r is the radius of the circular path. Now, since in the given scenario, the center of the cylinder is moving to the left with constant velocity v naught, since the center of the cylinder is moving, we can assume that bar is rotating about its center. Now let's assume that the radius of bar is r. The linear velocity of any point is v naught, and from the equation v is equals to omega r, we can write v naught is omega into r. Since the velocity v naught is constant, here it is constant, the angular velocity will also be constant, and therefore omega is equals to v naught upon r. Now for a constant angular velocity, the angular acceleration alpha is 0. Now for constant omega, the angular acceleration alpha is 0 because there is no change in angular velocity over time. And since the v naught is constant, the angular velocity omega will also be constant. Omega will also be constant. Here omega can be given by v naught upon r, which is the linear velocity, and alpha over here is 0. So I hope this answered your question. Thank you.